Hey guys, hoping all is well with everybody. So what we're going to do in this video is continue our practice algebra exam and starting with number 3. So let's hop right into it with question number 3. So our question number 3 says that x cubed minus 4x is equal to, and then all of our choices here, if you'll notice, are factored forms of polynomial expressions that we have to figure out which one is directly equal to x cubed minus 4x. Okay, so what I want you to first understand here is that there are, in factoring, you'll notice sometimes that you can use more than one method of factoring in a single equation that you're trying to factor. What I mean by that is, in this equation, we're going to be using two distinct types of factoring. So let's use the first one. Notice that in this expression, we can factor out an x from both of the terms x cubed and 4x. Remember, you can only greatest commonly factor something if it's present in both of the terms of your expression. So let's go ahead and do that and factor out an x. What I'm left with, and if you think about it, factoring is almost like a type of division. So if you take out x from x cubed divided by x, you're going to be given x squared as what's left. And pretty much what you're just doing is taking an account of what is left after. If you take an x out of 4x, you're left with 4. Now what this question wants you to understand and visualize is that this x squared minus 4 can also be factored. In fact, it can be factored in a very special way. This binomial expression x squared minus 4 is what is called a difference of squares. Notice that both x squared and 4 are perfect squares. When you take the square root of them, you get x for x squared and you get 2 for 4. That's what you're going to be doing as a general setup. So for the difference of squares factoring, if I have any binomial expression with the form a squared minus b squared, where a and b are just perfect squares, the form for the factoring is a plus b, a minus b. Okay? Now, so if we go ahead and do that, all we have to do is set x squared and 4 equal to what a squared and b squared is. So now if we take the square roots of both of these values, x squared being x, square root of x squared is x, square root of 4 equals 2. These are now our a's and b's. So a is going to equal x, and b is going to equal 2. So all we have to do now is go ahead, and again, we still have to account for that x we factored by greatest common factor. But then we can say and take the form a plus b, a minus b, because we've determined what our a and b are in this binomial expression. So we can say that x plus 2, x minus 2. Okay? And that is indeed the factored form of x cubed minus 4x. What I want to show you now is why the difference of squares works. When we do a difference of squares, what you're going to notice is that if you FOIL out the a plus b, a minus b binomials, you're going to notice that the outer terms and the inner terms of your FOIL method are going to cancel. And that's supposed to happen. Okay? So we'll take the x and we'll still account for that as we did earlier. X times x squared, or x times x is x squared, I'm sorry. Outer is going to be minus 2x, inner is going to be plus 2x, and then last is going to be plus 2 minus, times a negative 2, which is minus 4. Now, as I mentioned, notice how the negative 2x plus 2x, when you add those two together, you get 0. And that's supposed to happen. Okay? So all that you have left after that simplification is x times the quantity, x squared minus 4. And then all you have to do from there is go ahead and redistribute in your x term, and you'll get x cubed minus 4x. Okay? So this does indeed work, and as we do see, the factored form is x times the quantity x plus 2, x minus 2. Now for the remainder of this question, all I want to do is show you that when you FOIL out all the other possible answers, you don't get anything relatively close to x cubed minus 4x. So our first one's going to be, and I'm going to do this just kind of fast in terms of the FOILing just for the time constraints, but when you factor out x plus 1 times x minus 4, you're going to get x squared minus 3x minus 4, and then you still have to account for the x. You would get x cubed minus 3x squared minus 4x, which does not work, so choice A will not work. For the second one, it's going to be x squared minus 2x plus 1, and then you have to distribute in at 2x. So that would be equal to 2x cubed minus 4x squared plus 2x. So that choice won't work. For the next one, you're going to have x squared. And again, remember, I'm starting with the FOILing method and then distributing in the other variable outside. So x squared plus x minus 1. And then you're going to have to factor in a 2x. Yeah. This will be 2x cubed plus 2x squared minus 2x. So that will not work. And then the last one is going to be x squared minus 4x plus 4. And then distributing an x through that, that's going to give us x cubed minus 4x squared plus 4x, so that will not work. The reason that E is relatively close is that you do have the x cubed and the 4x, but the sign on the 4 is incorrect, as well as the inner term exists. It does not cancel out. Okay, so we do see that x times the quantity x plus 2, x minus 2 does work. Alright, let's look at the next question. So the next question, question number 4, states x plus 1 times the quantity x plus 1 times the quantity x minus 1. Now, and then your possible answers, they just want to see what it's directly equal to, is A, they have the form x minus 1, B is x squared minus 1, they have C equaling x plus 1, they have D equal to x squared plus 1, and they have E equal to x times the quantity x plus 1. Okay, so what I want you guys to really notice here in this one is this factored form of a binomial is another difference of squares that is factored. The reason I say that is notice that x and 1 are both perfect squares. And in fact, any variable can be a perfect square. So if we take this form, remember the a plus b, a minus b, this is that form. So we do have a difference of squares here. But just for sake of argument, let's go ahead and FOIL this out and see what we get. So the first term is going to be x squared, x times x. Outer is going to be minus x. Inner is going to be plus 1 times x plus x. And then plus 1 times negative 1 is minus 1. Let's go ahead and simplify that. Notice how your outer and inner of your FOIL method are going to cancel, because a minus x plus a plus x is 0. Then all you have left is x squared minus 1. Okay? Now, that is indeed a possible answer, and it is the solution. But let me explain why the other ones don't work in a little bit more detail. Okay, so starting with choice A, we do have x minus 1. This one's not going to be possible because remember with binomials and any terms that are connected strictly by parentheses, you're multiplying. And because this is a FOIL where you're going to have a degree of 2 as the x to the first power and x to the first power are going to be multiplied in some fashion, the lowest degree or the highest degree that you're going to have of this FOIL method is x squared, and you can't reduce that because there's no reduction or simplification of the variable x here once we determine that we get an x squared. So it's not furtherly possible to reduce it in degree. And we did say that choice B worked. C, it's kind of the same thing. You can't possibly reduce the power of 2 here because you are multiplying these two expressions. So when we get x times x, nothing in our simplification allows us to simplify this x squared term. Now what I want you to also be aware of is that x squared minus x is not x, okay? Those are actually not like terms. Remember, like terms are the same variable to the same exponent, okay? So that's why you would not be able to simplify a exponent in that kind of way. So it's kind of the same thing as choice A. You can't reduce the exponent of x squared. D is very unique. So x squared plus 1. There is no such thing as a sum of squares. There's no possible way to take a expression that has a squared plus b squared and factor it in a way that we did with a difference of squares. Okay? So that's what you gotta kind of be careful with. Also be careful with how you multiply your positive 1 and negative 1. Remember, positive times negative is negative. Negative times negative is positive. So that's why this one won't work. There's no such thing as there's no factoring way for a sum of squares, as well as be very careful of your positive and negatives. This one last here is just saying that can we just factor out a simple x from the first term and then leave the 1 or anything like that? And the answer is no. Remember that when we factor, we have to be able to factor out what we're factoring from both of the terms. So in order to factor this from the greatest common factor perspective, we'd have to take an x out of the first and second term. And since we can't do that, we can't possibly factor out that x. Okay. But this is the third and fourth question of the sample test. If you guys have any questions, again, never hesitate to ask me. But we will definitely see you guys in the next video, okay? Thanks for watching.